Okay guys, today we are going to cover day 2 in unit 1, which is key features of functions. We're going to start out with some definitions to help us get through the lesson. We are going to talk about domain and range. Some of this should sound familiar to you. Domain is the set of all x values that can be plugged into a function, and your range is your output values, the y values, from substituting in all of your x values. The minima and maxima, you'll hear me refer to as just min and max, but these are the coordinates, or sometimes just written with the y value, where the graph changes from going down to up for the min, and you're always going to read that from left to right, and this will be your bottom points. Your maxima is the coordinates, or sometimes written as just the y value, where the graph changes from going up to going down. Again, reading from left to right. These will be your top points. I do want to add right here, sometimes we have what's called a local or relative max and min, and this just means where it changes directions. So if you see that term local minimum, local maximum, or relative, that's just wanting to know how many places is your function changing directions. Sometimes we have the word that's called absolute, and this will be the absolute lowest or highest point on your graph. So if you'll just add that part to your notes there. So that covers your min and your max. And then we're going to discuss what's called increasing and decreasing intervals on the function. So your increasing intervals is where it's on the x-axis representing the portion of the graph that is going up from left to right. And you'll hear me say sometimes refer to or look for what seems to be positive slope. The decreasing intervals, it's the same thing, except for you're looking for what portion of the graph is going down from left to right. So when we're writing our intervals for increasing and decreasing, we're going to only use x values and we're going to only use parentheses from left to right. So that goes for both increasing and decreasing intervals. The last key feature that we're going to talk about is positive and negative intervals. So positive intervals is where your function is going to be above the x-axis, and then negative is where we're going to see our function go below the x-axis. So we're also here only going to use our x values and only use parentheses. So same as above on that. And what I'm referring to when I say parentheses is you'll write everything in interval notation. So what you may have used to have written as x is less than 5, meaning all values less than 5 is going to be written as parentheses negative infinity to 5. So if it's just less than or greater than, you will only use parentheses. So let's just make a few notes there. I'm just going to draw a set of parentheses there. This says x is greater than or equal to negative 4. If you have that equal to sign, you're going to use a bracket to write your interval notation. So if you notice, the bracket -4 to infinity, so that would say all numbers including -4 and bigger, basically. So in this case, there's no equal to sign, so that would get a parentheses. This is an equal to sign, so this is going to get a bracket. Okay, and that's just going to take some practice, getting used to writing it in interval notation. So let's look at this first example that we have. The first thing we're going to talk about is the domain. So if you look at the x values in this function, we start over here at -5 for our x values, but if you look, this is an open circle. Because of that open circle, that means that point's not included, so we're going to use a parentheses. So we're going to say -5, comma, and then if you follow your function, if you look at the arrow, you know that means it's going up. But it's not only going up, it's actually getting wider as it goes up, which means its x values are increasing forever. So we're going to say to infinity. Infinity will always get a parentheses. Negative infinity will always get a parentheses. So sometimes if you want to just go ahead and put your negative infinity and positive infinity on the ends of your graph, that'll help you. So this was our x values. Now we're going to look at range, which is our y values. So if we look at our y values, you want to start with the lowest point this graph is going to go. And if you look right here, the lowest y value is -3. And because that is included on the graph, that's going to get a bracket. And then the highest that this graph will ever go is positive infinity. And then we come to the local min and local max. So the local min, remember you're looking to determine where is it changing directions going from down to up. So here, this would not be a min. This is a min, so we're changing directions from going down to up. So our local min is going to be at the coordinate 2, -3. Or remember, I told you it could just be written as the y value, so we would say y equals -3. In this case, because this is the point, the lowest, the absolute lowest point this graph will ever go, this will be an absolute min. Okay, so for your maximum, there is a local maximum here at -3, 1. Or we would write that with the y value, y equals 1. And there's no absolute maximum because this graph increases forever. Okay, going up to infinity. All right, so increasing intervals. Remember, for increasing, we're looking for where is it going up from left to right. So I'm going to kind of label the places on the graph where I see increasing. So we're going up here. We would change directions, we're now going down, so all this would be considered a decreasing interval. We would change directions again, and then all this is considered an increasing interval. So we're going to write that, remember, using the x values only. So if I look here where the graph starts, and I come up to the x values, which I wrote over it, but that's -5. Again, because this is an open circle, we're going to use a parentheses, and it increases up to this point, but if I go down here and look at the x value, it's at -3. There's another increasing interval, so you write that. This is called a union, so you're going to say or. And then we're going to start again at this point where it changes directions to start increasing again. So that x value is 2. And then remember, it's going to keep going out to positive infinity. So then we have decreasing. We only have one interval in which it was decreasing. So if you look at that x value, it's at -3, and it decreases down to this point whose x value is 2. So that would be our decreasing interval. Positive and negative. So positive means where is this function above the x-axis? So there's 2 places it's above the x-axis. Use a different color here. So I'll try to highlight so you can see It's above the x-axis there, and it's also above the x-axis here. So we're going to write those looking at the x values only. So from -4 to -1, or, and then if I come here and look at this x value, it's +4 out to infinity. Decreasing is going to, or excuse me, negative is going to be, where is it below the x-axis? So I'll highlight that in blue, like that. So looking at x values again, I'm at -5. That's going to be -5 to 4. And then -1, excuse me, this should have been -4. And then -1 to +4 for our other interval below the x-axis, okay? So this had an arrow at the end, it would have been -infinity to -4, but because of this open circle, we're going to get a parentheses, and it started at an x value of -5. One other thing I want to throw on here are the zeros, and you've covered this before. And the zeros are where it crosses the x-axis, also referred to as the roots. So we've got one at -4, so we're going to write x equals -4. There's another one at x equals -1. And then the last one is at x equals 4.